Alright, welcome back Bass Modders. Just taking a little break from Project Barocca for the moment because look what I've got. It's I believe, I've been told it's a 1978 model. I'm not a StingRay historian, but I do love old StingRays, especially the way the original pickup and preamp was designed. I kind of think it was one of Leo's masterpieces of electronic engineering. This guy, I've already taken the battery out, and it is a refin. You can see it was originally white, but apart from that, I believe it's more or less original. Oh, and it's got a drop D machine head thing. The owner tells me there's problems with the electronics, so the battery voltage was 0.0. It was absolutely dead flat. So I'm not just going to put a new battery in and plug it in. That might be a bit risky. I'm actually going to pull it apart first and just double check there's no short or something like that before I plug it in and test it. So let's have a look. Ooh, okay. So I can already see a couple of problems. The first is this pickup wire. There's no insulation on this soldering, and if that so much as touches anything that's earthed, it will have no output at all. It acts like a mute switch. The jack's been replaced with oh yeah, so someone's replaced the jack with a regular mono jack, and it really needs a stereo jack. And the battery negative is just earthed, so it's just going to continue to draw current, and I think that's why the battery was absolutely dead flat. To be honest, all of this soldering is, well, it's kind of poor. I don't want to tread on anyone's toes there, but this is quite amateur. All of these joints are dry. Electrical tape eventually just gets all soft and gooey and just comes off like that. That's a bit gross. And again, these soldering joints are not very well done. The volume pot has been replaced, but it looks like it's been replaced with the correct item. This is actually a 25K audio taper pot, which is what these preamps require. It's actually wired on the output of the preamp. This looks like an EMG part. That's why it's got the V on it. They used to ship with EMG pickups back in the days before the solderless connections were a thing. Another problem is that there's no continuous soldered wired earth connection. Everything's earthed up to the pot casings, and I know that's done in a lot of bases, but the problem with that is that as soon as one of these pots becomes loose, and it's quite common, or the jack becomes loose, then the circuit doesn't work. This is also very corroded, and the plating's starting to come off and everything, so that might be a problem as well. So I'm actually going to do proper earth connections up to the jack when I replace the jack. Now I believe this pickup should read around about 2K because, well, the modern ones generally have pickups or coils wound to 4K and they're wired in parallel. I think the early ones actually was even less wound than that, but let's have a look. Oh, there you go, 1.9K. Well, it looks like the pickup's hopefully still working. Alright, these pickup wires have been cut really short, and I really need to resolder these joints, so I'm just going to have to take the pickup out, I think. Just going to measure the pickup heights first. That way I can put it back in the same position as the owner has it. Okay, so I've got new pickup wires. They've been soldered properly, and there's heat shrink material on there. But while I've got the pickup out, it might be nice to do some testing on it and just see how these old 70s pickups work and what their resonant frequency is and all the rest of it. So let's have a look. So I've got the StingRay pickup hooked up to my USB scope. It looks like the resonant frequency is right on 10 kilohertz. And it's exactly where it should be, I think, for a late 70s StingRay pickup. Its DC resistance is 2K, or just under. It has exactly 1 Henry of inductance, and it has a stray capacitance of 246 picofarads. And as I mentioned, the resonant frequency of the pickup is 10 kilohertz, or very close to that. I think it was 10.1 kilohertz. I'm not about to pull the two coils out of the cover and desolder them or anything. You really want to avoid that with a vintage pickup like this. But it's safe to assume that the two coils are more or less the same. So that means that each coil has a DC resistance of 4K and 2 Henrys of inductance, because obviously they're wired in parallel. Anyway, I better get on with the repair work. Here's the battery snap that was in the base. I don't believe it's original. It looks very much like the ones that EMG used to use. The terminals are quite corroded, so I'm going to get rid of that. And I'm just going to use one of these modern heavy-duty sort of clips. So I think I'll also redo the string earth. The original wire had been soldered and resoldered, and it was basically a single sort of strand of wire left in here. I guess it had been tugged or removed or something. So normally what I do is just use a piece of copper foil. Okay, there's just a little blockage or a snag in there. So I've just tacked that onto a piece of stiff wire. That should be okay. I'll push that through now. There we go. So I'll just tin this end. Cool. So here's our preamp. That is our output wire. That looks like it just comes straight from the wiper of the volume pot, sort of through all of this epoxy as a single piece of wire to the jack. I'm just going to double check that. Simply a matter of testing the continuity from the wiper. Yep, so that's our output wire. This is the input wire from the pickup. Looks like the black is the output wire from the preamp, but for now it's actually really short, plus this solder joint I don't really trust, or really any of these extra solder joints. So I'm going to redo the volume pot with some slightly longer wires, and I'm also going to test that volume pot as well. Okay, so there's a few problems here. The earth wire is soldered to the pot casing, and I'm not sure whether it was like that from factory, but of course if that pot becomes loose as it is, then that can stop the preamp from working. It's the same story with the jack. It's been replaced not only with the wrong type of jack, but there's no shake-proof washer. There's another issue here too, is that all of this chrome plating is all corroding and flaking. And I'm a bit nervous about that sort of floating around inside the electronics cavity, getting inside pots and so on, and causing problems. It's clearly whoever's worked on the base has not got a lot of experience. They've actually put the shake-proof washers on the top side, which is a bit of a rookie mistake. But I think I can fix it all up. I think I'm going to take the preamp right off this control plate. I think I'll rub back some of this loose plating and maybe just spray a clear sealer on it to hopefully stop that from shedding as it is. So yeah, I think that's my next step. Okay, so here's the very famous StingRay 2-band preamp circuit. Even though our circuit board is all gooped up in black epoxy, there are some access points. That is, of course, the wires to the pots. So there's a couple of things we can test. The wiper at the treble pot, you can see, is connected directly to pin 2 of the op amp, and that has an ohmic connection to the output. And both of the wires at the base pot are also connected ohmically to the output, and the output should be at the bias voltage, and that's set at pin 3 by these two equal sized resistors, 2.2 meg resistors. And that means that these wires at the wiper of the treble and the two wires to the base pot should be at the bias voltage, which is half of the supply voltage. Okay, so the first thing I'm going to do is test the current draw. I can do that with just one battery terminal hooked up. So about 30 microamps. Sounds amazing that a preamp would work on such a tiny amount of current, but that's about right, I think, for this particular op amp and the way it's configured in this preamp. Okay, so now I can test some of these other DC voltages. The battery here is exactly 9 volts, so the wiper of the treble pot should be 4.5, and I think the wiper of the bass pot, or both terminals actually, the bass pot should be 4.5. So there you go. So it looks like the preamp's functioning properly. Another thing that's worth testing, especially with an old circuit like this, is that there's no DC or voltage across the input and output. There is input and output coupling caps. Ooh, there is a tiny voltage there, but it seems to be slowly dissipating through the multimeter, so that looks okay. Let's test the output. Ooh, that's not good. The output's actually sitting at the bias voltage and it's not shifting. I guess that means that the output coupling capacitor is a short circuit. These little teardrops on the circuit board here are tantalum caps, and when they fail, they generally fail to a short circuit, or so I believe, so I've read. That's not good. You really don't want DC running across your volume pot, or really any pots in an audio circuit. So if we go back to the schematic, here's our output coupling cap. This particular schematic that I've downloaded says 1 microfarad here, but I think the cap should be 10 mic. And this, I guess, is our output wire between the output cap and the volume pot. And initially I was just going to cut this and put a new cap in here. But tantalum caps really aren't used in audio circuits that much these days, and I'm not really sure how stable this will be after it's shorted the way it is, whether it will degrade further over time or whatever. And it's really not good practice to leave faulty components in a signal path like this. So what I'm going to do instead is I am going to cut this wire, but I'm going to just heat shrink it and just sort of terminate it. That way this existing cap is just, electronically speaking, just dangling from the circuit with one leg connected and one free. And that way it can't do any harm, it can't play a role in the circuit anymore. What I'm going to do instead is actually run the output from the wiper of the bass pot. And that's because luckily, I mean really luckily, with this circuit, it's connected to exactly the same node. So we can actually access that node from the wiper lug on the bass pot. So I'm just going to run the output wire from there, put our new cap in there, and then hook that up to the volume pot that way. I just have to make sure I wire this in the correct polarity with the positive side to the bass pot. Obviously that's our bias voltage there, which is 4.5 volts, and the negative side to the volume pot, which will be 0 volts because of its earth connection. The only other thing I have to really think about is where and how to mount this replacement output coupling cap. I guess I could just heat shrink it with a couple of wires coming out of it and sort of cable tied in place, but instead I think I'll actually glue it to the back of the volume pot. That way I can run the negative lead directly to the volume pot clockwise lug, and that should be fine. It's going to look a little bit unorthodox, but the circuit will function absolutely perfectly that way. And I've kept the original circuit in the base, which I think is not a bad thing. So this lacquer has kind of dried. It's a rust-inhibiting, anti-corrosive lacquer. And all the flaky bits seem to be sort of stabilized. Let's hope it works okay. So now I can just mount all of these bits and pieces back on. I'm going to use new shake-proof washers for all of these as well. And here's my brand new Switchcraft jack. I'm going to put a second washer on that so it sits flush on the front. So now it's time to wire this back into the base. The first thing I have to do is hook the pickup wire to the input wire. Slide a piece of heat shrink on first. I guess the next thing I'll do is hook up the positive side of the battery. I've actually wired in, not sure if the camera can see it. I've actually wired in a little silicon diode there. It's what they call a reverse polarity protection diode. Virtually all modern audio circuits, battery operated or otherwise, will have something like that in them. The new StingRays all have a polarity protection diode. It's possibly the reason that tantalum cap was shorted in the first place, was that isn't there. It really doesn't affect the circuit in any sort of aural way or any sort of audio way. It does drop the battery voltage across the circuit by about half a volt, but in practice that really makes no difference, especially with such a low current draw device like this. So I'm going to put that in. Okay, now I can wire this the negative side of the battery to the ring connector on the jack, which is this guy here. Oop. No, it's not. I've got those two mixed up. Let's try that again. Take two. Okay, I've got that sorted out. I mixed up the two lugs. This is the tip connector. That's our hot output from the preamp, or actually from the volume control. And that is our negative battery, which goes to this terminal here, which is the ring connector. So finally, all I have to do is just gather up all the earths. That's from the pickup. That is the string earth. That's from the circuit, and that is from the volume pot. So I'm going to crank my heat a little on the iron for this big earth connector, especially since it's all connected to this big metal plate. So I've just installed a battery in the back. It's time to test this guy out. Well, it all seems to work okay. Let's get it strung up and back on the road. So just a couple of cable ties to neaten things up a bit, I guess. I've also spent a bit of time making sure all of that flaking chrome stuff has all been removed from inside the cavity. So I just need to bolt it down, string her up, and see how she sounds. Actually, before I do that, there is one other thing I like to do with these sort of things. I'm going to put a cable tie on the battery cable, and that'll stop it being tugged on from the other side. I think about there. Have So be really careful not to pinch the wires as well when you put this down into place. So now you can't tug on the wires if that gets pulled. So yeah. Well, it seems to sound alright. Needs a bit of a setup though, it's hard to play, for me anyway. All I have to do really is just put one of these little adapter bushings on the volume pot so I can put the knobs on. And I haven't installed the battery cover yet just because I've noticed it's kind of starting to flake as well. So I'm going to give that the same treatment as the electronics cover, and this will be all ready to go back to its owner. So thanks for watching, hit subscribe. I'm doing a bunch of videos on this orange base at the moment. It's called Project Barocca. Check that out on my channel as well, and I'll see you next time.